Okay, everyone, let's do an example of a randomized hypothesis test, or in other words, statistical decision-making using randomized simulation. So let me share this out to you. Okay, this is where we left off in the previous video, is that this is the overview of how randomized simulation works. What we need to do now is we're going to use a tool which you saw in last week's lessons, a tool that will build this random simulation for you and do all the calculations of the statistics. So here's the situation. If a jury in a community with 33.3% minorities was selected with only one minority out of the 12 jury members, then is there evidence of some sort of discrimination in the jury process? So this is a real life situation. So we have a population that is a third minority. Juries are supposed to be fair. They're supposed to be representative of the population in which the person lives. And so 1 in 12, well, 1 in 12 is not 33%. It's much, much less than that. It's like 8%. So do we actually have some sort of discrimination or some sort of minority bias happening here? So the question we want to answer is there jury selection bias? The null hypothesis is, you always have to think about the null hypothesis as a statement that nothing weird's happening. So in this case, if I assume nothing weird's happening, then I assume 33.3% of our juries should be minorities. So a 12-member jury should have 1/3 minority. Okay, that's going to be our null hypothesis. Then we're going to use the stat key tools to generate many random simulations. So let's jump in. Okay, so I'm here over in stat key, and you're going to find the link to stat key down below this video. So I need you to follow along with me here. I'm going to click test for single proportion. I'm choosing single proportion because I'm looking at the proportion of minorities in my jury. One single proportion. Okay, now we've seen this screen before. This was from last week, but now we're layering a little bit on top of this. My null hypothesis was a statement that there's nothing weird happening. So in this particular case, that would mean that 33.3333% of my jury should be minority. Okay. So now I've got my null hypothesis to reflect that. Now my data, I had one person out of 12 people who actually showed up to be minority. Okay, so if we want to think about the idea we have here, so far I've told you what the null hypothesis is. And now I'm giving the computer enough information to build many different juries of exactly the same size, 12, assuming that the population they're pulling from is 33% minority. So that's what I'm telling it here. I've got 12 people in a big population. So I'm pulling samples of size 12 out of a huge population. And in that huge population, 33% are going to be minority. So if I generate a single jury, all right, now the single jury I had happened to have 33% minority. Let's generate another jury. That particular jury ended up having almost 60% minority people by pure random chance. Let's generate another one. Here's another jury that had 50%. Here's a jury that had 41.7% minorities. Here's a jury that had 25% minorities. Here's a jury that had 16% minorities. Now, it seems so far that juries like ours are not showing up very often. So again, let's think about this. I'm generating many, many different random samples based on the hypothesis that there is a 33% chance of picking a minority. Well, let's generate thousands of these. I'm going to click this a couple of times. Okay, so let's say we get up to a little more than 5,000. Now, clearly, this is now a hypothetical situation. I'm clearly not going to go gather 5,000 different juries by hand. That's not possible. The whole idea of randomized simulation is we use the computer to go gather those for us based on this assumption. Okay, so I'm going to recap a little bit here, and I'm going to fill this in. My null hypothesis, I think of that as nothing strange is happening here. My null hypothesis states that I should have about 1/3 minority membership. Now, the alternative hypothesis, the thing that we want to test against, is that juries in this particular community actually have some sort of bias. So there is some sort of minority bias in the jury selection process, and the real proportion of minorities is less than 33.3%. Okay, now what I've done over here is I've built up what's called a sampling distribution. And now I judge my sample on that sampling distribution. Now I said that I think there's bias happening. So I think that my jury is actually on some other distribution which has less than 33%. Less means left. Well, let's see. My 8 point something percent, and I'm going to keep gathering samples here, under repeated random sampling, my 8.3% shows up about 5.4% of the time. So we find our data that is a jury with 8.3% minority membership. About 5.6? Yeah, 5.4. Yeah, 5.5, something like that. So about 5.5% of the time. Now we need to make a decision whether or not that's rare versus not so rare. Now in statistics, we usually use 5% as the cutoff between rare and not so rare. So if we say that 5% is kind of our arbitrary cutoff for rare versus not so rare, then we would say our data is, well, God, I said this is not very rare. In other words, yeah, it happens near 5% of the time, but not really less. Okay? But I want to warn you against making a black and white decision here. All right, our data is close to 5%. So if our arbitrary cutoff was maybe 6%, to say rare versus not so rare, then we would call 5.5 rare. So I would say, but it is close. So we may have some evidence that there might be jury bias. Notice all the wishy-washy words that I'm using here. We may have some evidence that there might be jury bias. I'm not using very definitive words here because statistics is based on randomness and variability. And under random chance, about 5.5% of juries will actually have only one minority juror, even though the population has a full third minorities. That's pretty rare, so it might be that we have some bias. Okay, I need you to stop now and really take careful notes on what we just did, because that was the full process of making statistical decisions. And if you need to, watch this video again.